efficient architectures, and frontier models. Here is your same structured, beginner-friendly content for efficient architectures and frontier models, beginner-level introduction. Efficient architectures and frontier models are advanced AI concepts focused on building powerful yet optimized AI systems. Modern AI models are becoming larger, more complex, more powerful, but they also require high compute, large memory, expensive infrastructure. To solve this, researchers focus on efficient architectures, means make models faster and lighter. Frontier models means push the limits of AI capabilities. Examples include efficient transformers, sparse models, small language models, SLMs, state space models, SSMs, large language models, LLMs, like GPT. This topic helps beginners understand how AI balances performance and efficiency. What are efficient architectures? Efficient architectures are AI models designed to check, use less memory, run faster, reduce computation cost, maintain good performance. In simple words, efficient AI equals powerful models that use fewer resources. What are frontier models? Frontier models are the most advanced AI systems available today. They are highly capable, trained on massive data, used for complex tasks. In simple words, frontier models, cutting-edge AI systems, pushing boundaries. Examples of efficient architectures: distilled models, DistillBERT, quantized models, sparse neural networks, mobile-friendly models, SSM-based models, like Mamba. Examples of frontier models: large language models, LLMs, multimodal models, text plus image plus video, AI copilots, autonomous agents. Efficient versus frontier models. A comparison. Feature: efficient models, frontier models. Size: small to medium, very large. Speed: fast, slower. Cost: low, high. Capability: moderate, very high. Deployment: easy, complex. Why efficient architectures are important. AI systems need to run on mobile devices, edge devices, real-time systems. Efficient models help by check, reducing cost, check, enabling faster response, check, supporting scalability, check, running on limited hardware. Why frontier models are important. Frontier models help, capital S, solve complex problems, improve AI capabilities, drive innovation, enable new applications. Example of efficiency concept numbers equals 1, 2, 3, 4, 5. Total equals sum numbers. Print total. Efficient code performs tasks quickly with minimal resources. Example of model optimization. Model size equals 100. Compressed model equals model size times 0.5. Print reduced model size, compressed model. Simple AI efficiency example, Python. Def efficient model, data, return sum data. Print efficient model 1, 2, 3. How efficient architectures work. Step 1. Reduce model size. Size equals 100. Size equals size divided by 2. Step 2. Optimize computation. Print using fewer operations. Step 3. Maintain performance. Accuracy equals 90. Print maintained accuracy. Techniques for efficient AI. Quantization. Reduce precision to save memory. Pruning. Remove unnecessary weights. Distillation. Train smaller models from large ones. Sparse modeling. Use fewer active parameters. Caching. Reuse computations. AI and frontier models. Frontier models can generate text, understand images, write code, answer complex questions. Query equals explain AI. Print. Generating advanced response. AI in multimodal systems input data equals text, image. For data in input data, print processing data. AI in real-world systems. Efficient plus frontier models are combined. Task equals chatbot. If task equals chatbot, print using optimized AI model. Full menu-based example. Def optimized model. Size equals int input enter model size. Size equals size 12. Print optimize size. Def run model. Data equals input, enter data. Print processing, data. Def compare models. Print efficient model, fast and low cost. Print frontier model, powerful but expensive. While true. Print N1 optimize model. Print 2 run model. Print 3 compare models. Print 4 exit. Choice equals input, entered choice. If choice equals 1, optimize model. Elif choice equals 2, run model. Elif choice equals 3, compare models. Elif choice equals 4, break. Else, print, invalid choice. Column initialized. Column optimization techniques. Trade-offs, speed versus power, advanced AI systems. Real-life analogy. Efficient AI equals fuel-efficient car, fast, low cost. Frontier AI equals sports car, powerful, expensive. Ways to improve a project. Use quantization tools. Apply pruning techniques. Deploy on edge devices. Compare multiple architectures. Use cloud AI services. Optimize inference time. Explore new research models. Combine efficient and frontier approaches. Common mistakes beginners make. X. Thinking bigger models are always better. Ignoring cost and latency. Not optimizing models. Overusing heavy models. Ignoring deployment constraints. Where these are used. Mobile AI apps, cloud AI systems, chatbots, autonomous systems, search engines, recommendation systems, robotics, enterprise AI. Large systems may include LLMs, multimodal models, edge AI systems, distributed AI platforms. Simple definition. Efficient architectures. AI models optimized for speed, cost, and performance. Frontier models, advanced AI systems, pushing the limits of intelligence and capability. Final summary. Efficient architectures and frontier models represent two sides of modern AI. Efficiency means practical, scalable AI. Frontier means powerful, cutting-edge AI. Together, they help build balanced AI systems for real-world use.